guys. I'm very sorry I can't be there in person. I have a 3-month-old baby who does not like to sleep at night, so I've not been allowed to leave the house, I'm afraid. But anyway, hopefully this will still be a useful talk for you all. We're going to be talking about Elixir compilation, and I'll get straight into it. So, has anyone had this experience where you change one file? Maybe you're doing TDD, right? And then suddenly it's compiling like a bunch of other files, a bunch of other completely unrelated files. And it slows you down, maybe it takes 10 seconds, and it makes you a little bit sad, a bit like this puppy. On the upside, gives you a little bit of time for perhaps some sword fighting, so that's something. But, a bit of a pain. So this talk aims to help you understand why this happens, some of the underlying kind of things about how the Elixir compiler works, and then it will give you some tips for how to stop this happening in the future and speed up your kind of feedback cycle. So the first thing to cover is, how does the compiler decide what to recompile? So when you write Elixir code, some of it gets executed at runtime, and some of it gets executed at compile time. The rule of thumb is that if some code is in the body of a function, it's evaluated at runtime like this. If it's outside of a function body, so just in the module, then it's evaluated at compile time. So you can see when we compile this example, what we actually end up with that's being run is this, right? So when you run your code, this 2 + 2 calculation isn't being done. That actually gets done at compile time. And of course, this would be a beam file, but didn't think that would be quite as readable. So the next thing to understand is dependencies. We'll start off nice and simple, runtime dependencies. So a runtime dependency is when you have something like this. Here we've got module A and it calls a function in module B. So we'd say that module A has a runtime dependency on module B. Nice, simple graph. So hopefully you're still with me. The other type of dependency is a compile time dependency. Very similar, except this is when you have some code that's right at compile time. So remember, that's in the module body, not within a function. And that compile time code calls another module. So here we're calling the module CTB for this do maths function. So we'd say CTA here has a compile time dependency on CTB. Hopefully still quite simple. So again, if we look at the compiled code, you can see once you've compiled it, this calculation isn't getting done. And we've just kind of substituted in the for here. Now, the important thing about compile time dependencies is that if we change CTB, so here we've added this +10 down here, that actually also changes the compiled code for CTA. So just flicking back, before the compiled code just said for, now we've changed CTB and it still changes the compiled code for CTA. So of course, this means we'd have to recompile both modules. It's also worth flagging that these compile time dependencies aren't like that intelligent. They are only kind of recognize dependencies at a file level. So even if I change something else unrelated in this CTB module, it would still cause CTA to be recompiled. Right, hopefully still with me. It's about to get a little bit trickier. The next thing to talk about, and the most kind of gnarly bit of this talk really, is transitive compile time dependencies. So this is an example. Module A here has a compile time dependency on module B, just like we saw before. The catch is module B then has a runtime dependency on module C, because it's calling the c.add function. So we end up with a dependency graph a little bit like this. What that means is that A now has a transitive compile time dependency on C. That means if I change anything in this C module, it also is going to recompile module A. So if that doesn't quite make sense why that would be the case, let's look at an example. So if we compiled the code there, you see we end up with the compile module for module A has kind of just 4 here, right? It's going to call this do maths function, 2 and 2, 2 + 2 is 4, right? Simple. Now, what if we change module C? So here, if we do a +10 in module C, you'll see it's actually changed the compiled code for module A. So that kind of hopefully explains why we'd need to recompile both of those modules. Hence, this kind of dependency graph. So hopefully you've got all of that, right? So I'd like to invite you to join in if you have a phone or your laptop handy with a quiz where we can test your knowledge or maybe test how well I've explained that. So we'll go through a bunch of examples and yeah, we'll see how we get on. So I'll just give people a minute to join. We've got a bunch of people joining. There will be a leaderboard. If you win, you'll be able to put it on your LinkedIn profile. You can feel very, very proud. So yeah, definitely encourage you to join in. All right, okay, we've got a few people on the quiz, so we'll get going. The link's on all the slides as well. So if you've not joined yet, don't worry. It's on all the other slides as well, so you can still join in. All right, we're going to start nice and simple. If we edit module A1 here, what will be recompiled? You get about 20 seconds to answer each of these. Oh, nice variety of answers. That is what I like to see. Got about 5 seconds left. All right. Cool. When you edit A1, only A1 will be recompiled. So in this example, there are no compile time dependencies. There's only runtime dependencies. So if I change A1, only A1 needs to be recompiled. It's only when we have compile time dependencies that you end up having to recompile other modules besides the one you edited. All right, another example. How about here? If we edit module A2, what will be recompiled? Some very speedy answers coming in. Feel people feeling quite confident with this one. All right, just a couple of seconds left. All right, so when you edit module A2, both A2 and B2 will be recompiled. That's because module B2 has a compile time dependency on module A2 because of this call here, A2.a. All right, now, if we edit module B2, what will be recompiled? About 5 seconds left. A few more answers coming in. All right, so when you edit B2, only B2 will be recompiled. B2 does have a compile time dependency on A2, but that's only one way. A2 does not depend on B2 at all, right? So yeah, only B2 will be recompiled. All right. Now we get a little bit more interesting. So just before this question, quickly show the leaderboard. It's managed to break. I can tell you that William and Jonas are at the top of the leaderboard. So well done, guys, and a few other people. So yeah, lots of people doing quite well on this. So now next question, if we edit module A3 here, what will be recompiled? Getting a bit trickier here. So I could give you a little bit more time. You may not be used to, building these dependency graphs just in your mind, but I assure you by the end of this talk, you'll want to do nothing but. Yeah, much trickier question. Much bigger variety of answers on this one. Okay. So when you edit module A3 and C3 will be recompiled. So well done if you got that right. Let's follow why that is. C3, so a general tip when looking at these, right? Start by looking at where you have a compile time dependency. So the only place we've got one here is in module C3. It's got a compile time dependency on B3, and B3 has a runtime dependency on A3. So you can see that when we change A3, anything with a compile time dependency or transitive compile time dependency on it gets recompiled. So that means just A3 and C3 get recompiled. All right, let's make it a little bit harder. if we edit B4, what gets recompiled? Yeah, people take a bit more time to think about this one. About 5 seconds left. All right. Again, good variety of answers. Much trickier question. So, likewise, let's start with the dependency graph, and we'll start with module D4. Module D4 has a compile time dependency only on module A, and module A has no runtime dependencies. So when we change B4, well, nothing's got a compile time dependency on it. So that's the only thing that will get recompiled. All right. Next one. This is my favorite question. If we edit B5, what will be recompiled? And when I wrote this question, I definitely didn't get the answer right. Just chuckling as I see the answers coming in. Yeah, a few people have got it. When you edit B5 here, the compiler will actually hang. So a bit of a trick question. Why does that happen? Well, at compile time, we're going to call a5.a. That then calls the C module. That then calls the B module. That calls the A module. That calls the C module. That calls the A, and round and round and round it goes. And it never stops, and the compiler just hangs. So yeah, well done if you figured that one out. All right, so if we fix that little issue, what gets recompiled if we now edit B5? About 10 seconds left. All right, so B5 and D5 will both be recompiled. It's quite, I think, an interesting example and one that causes a lot of problems in code bases. So let's walk it through, right? So D5, again, starting with the interesting kind of compile time dependency, depends on A. A depends on C at runtime. C depends on B at runtime. B depends on A at runtime. And you get this beautiful little, to call it a dependency cycle, right? Where you've got this circular lot of dependencies. What that effectively means, right, is that D5 now has transitive compile time dependencies on both B and C, right? So now when any of these files change, D5 will also be recompiled. So yeah, well done if you got that one right. All right, hopefully you guys are still with me. There is a slight addition to the quiz later on. Let me just bring up the leaderboard again. No one's on top marks so far, but Jonas, Jacob, Mikhail, Caroline, all doing very, very well. So there is a few more questions later on, but hold still for now, and we'll go through a little bit more material. So I've been slightly oversimplifying. There is one more type of dependency, a bit less important, but still useful to know about. That's called an export dependency. So an export dependency is like a compile time dependency, but with a compile time dependency, if anything changes in that module, it causes a recompilation of both files. With an export dependency, it's only if the API of the module changes that it causes recompilation of both files. What do I mean by the API of the module? I mean either a definition of a struct and it changes, or a function is added or removed, or a function signature changes. That means like the number of arguments in a function changes. So there's two ways that you can get an export dependency. One is if you have a dependency on a struct. So here you can see my app cares about this person struct here. So my app has an export dependency on person. And the other type is when you use an import. So here your app imports helpers here. And that means that your app has again, an export dependency on helpers. So again, just as a refresher, when you have an export dependency of either type, Any change in that module API will cause the other file to also be recompiled. Did that make sense? No? Well, it's time for another quiz anyway. Last few questions. Bear with me. So if the field height were added to the struct defined in module A6 below, which files would be recompiled? Just 20 seconds for these ones. Don't have to hold quite such a complex diagram in your heads for this. All right, people feeling pretty confident with this. So well done. All right. I think so. When we add a new field to a struct, the API of the model has changed. This has an export dependency on A6. So yeah, both files will be recompiled. All right. So very similar kind of example here. If function A, this function here, was updated to return the string B instead of the string A, which files would that cause to be recompiled? Yeah, bit trickier, this one. Just a couple of seconds left. So when you change a function implementation, it doesn't change the module API. So only module A6 here would be recompiled. By changing the return value, we haven't changed the module API. Like if we'd added an argument to this function, that would change the module API and it would cause both to be recompiled. But in this case, just change the output. I've totally just given away the answer to the next one. If we add a new function to module A8 here, which files will be recompiled? Just a few seconds left. All right. So that is quite right. A lot of people got this right. When we add a function here, we have changed the module API, and there's an export dependency because of this import here. So yeah, both files will be recompiled in this case. Let me quickly bring up the leaderboard. I might have to share a different screen. So Jonas, well done, because you got 9 out of 10 questions right. More correct answers than anyone else. So good job. And honorable mentions to Jacob, SD, Caroline, and Macau, all 8 out of 10. Lots of other people doing really well here. So yeah, well done, everyone. I hope you enjoyed the quiz. But I guess what you really want to know, right, is not just why this stuff works like it does, but how do we actually improve our compile times now? So when I was trying to solve this in Multiverse, the first thing that I tried to do was get rid of all our dependency cycles. We had a total of 465 runtime dependency cycles with a combined length of over 10,000 files. So you can imagine that when I tried to get rid of all of these cycles, I felt a bit like I was chasing my own tail. I would not recommend this to be where you start, right? This is where I recommend you start. So if you have a module that has compile time dependees, that's people depend on it at compile time, I would highly recommend that you make sure that module doesn't have any other runtime dependencies. So this is bad, right? We've got this module, people compile time depend on me. 2 people have got these compile time dependencies on it, and it also has runtime dependencies on the files. Really, really bad, because it results in this messy dependency graph, right? Everything just depends on everything else. Dependee 1 has a transitive compile time dependency on these 2 modules. So does dependee 2. Now, if we change either of these, like, it just causes loads of stuff to be recompiled. So really, really horrible. Please try and avoid that in your code. This is how you fix that kind of thing. So here we've got the module people compile time depend on me, and you'll see that I've removed the functions that call out to other modules. Instead, I've put them in some different module here. And so our dependency graph now is much, much neater, right? There's no runtime dependencies for this module with compile time dependencies. And this has totally removed every transitive compile time dependency. So it's a really nice way to fix these kinds of things. So that's how you fix it. How do you find out where those issues occur in the first place? So this is how I would go about it. First, find files with transitive compile time dependencies on the file that you're editing. You can do it without any file, by the way, but I just find like if I'm working on a particular file and it's annoying me, I'll kind of start there. So this command really helpfully tell you all of the files that end up being recompiled, and it will tell you what compile time dependency they have. That's kind of the root cause of that file being recompiled. So you can either try to remove that compile time dependency. It's like if you're using module attributes, you could just get rid of them and just call them in the body of your functions instead. Or the other thing you can do is use that technique I just showed you to try and like separate out your modules. So if anything compile time depends on you, try not to have any runtime dependencies. A few other tips. You could consider using alias instead of import. Like as we saw, import creates these export dependencies, which can mean more files get recompiled. It's a bit of a trade-off. Like sometimes using import is nice to not have to put the full module name every time, but worth a try. I said, like, I kind of gave up trying to get rid of our dependency cycles, but it is still good to get rid of them if you can. And this little function here will help you like identify all of them. So yeah, that is something worth doing. Worth flagging that particularly with like Phoenix, right? Some dependency cycles are inevitable. So let's say you've got like your router, it calls out to a controller, that controller calls out to a view, and maybe in your HTML, you've got a link to another page in your app. Now, how does it know what that link is? It has to look at the router, right? So you've got a circular dependency there already because you depend back on the router and so on and so forth. So yeah, it's impossible to get rid of all of them, but it can be still good. The other thing is if like you're in a bad position and this is happening a lot and you've got a lot of transitive compile time dependencies, profile your compile time, right? And see what's the thing that's really killing it and just focus on those things first. And the last thing, just to plug the blog, is that you can check out the blog post series, which has kind of everything that we've talked about. If you just Google Elixir compilation, hopefully it's still like up near the top of the results. And that's all. So any questions?
Okay, excellent. Thank you, Tim. Yes, we do have question in the Q&A in Huva. One question asked by Jack. Where do you think people most commonly have these issues in everyday code bases?
I think for me, one of the biggest things is like you just have a module that consists of some constants as well as some like function calls. So for ours, like maybe we'd have a module about apprentice statuses, right? And there might be some constants there, like with all the different statuses. And there might also be some functions about how to update those statuses. That's a kind of bad thing, because what we tend to do in our codebase, I'm sure other people do as well, is have module attributes in other files that refer to those constants. So as soon as you do that, you've got a compile time dependency between this file with a module attribute and the one that defines the constants. What, again, I'd recommend is splitting out those constants that you have compile time dependencies on, and then the functions into separate modules, and that gets rid of that kind of messy situation.
Cool, thank you. Another question. So at Multiverse, how much time you were able to reduce the compile time using these points you mentioned in the presentation?
Right, so this is from memory, so probably slightly wrong, but I think it was around 8 seconds off of incremental compile times, which if you're a TDDer like me, kind of really adds up across the team and across your working day.
Over every iteration, 8 seconds, yeah, adds up, yeah.
After every file change, yeah.